So let's look at this one here now. Limit as x goes to 0, the positive direction. So we're, again, unit circle wise in the first quadrant. So we approach 0, so stuff is positive. Of course, as we go to 0, cotangent is cosine over sine. So cosine's going to 1, sine's going to 0. So cotangent's going to infinity. And then we're raising that to the x power, which is going to 0. So we are dealing here with an infinity to the 0 power limit. So once again, when we have any of these exponential limits, 0 to the 0 to the 0, 1 to the infinity, or infinity to the 0, we take care of all of them the same way. So we apply ln to this stuff and work that limit out first. Then we proceed to deal with our original limit. So limit as x approaches 0 from the positive direction of the ln of the cotangent of x to the x power. Okay, so using our properties of logarithms, we bring the exponent out. So the ln of the cotangent of x. And that transforms our problem now from an infinity to the 0 to now a 0 times infinity limit, because x goes to 0. We already know cotangent goes to infinity. As you go to infinity, ln is infinity. So we have a 0 times infinity limit. So remember, we always do that by taking one of those things divided by the reciprocal of the other. And of course, it makes the most sense to put the ln of the cotangent on top, because that's the more complicated thing. Divided by the reciprocal of the other one. Okay, so let's start to work this out. See what kind of progress we can make here. So taking the derivative of the ln, that would be 1 over that stuff, so 1 over cotangent x, times the derivative of the cotangent x, which would be negative cosecant squared x. Okay. That's all divided by the derivative of 1 over x, which would be minus x to the minus second. Okay, so I'm going to do some housekeeping here to try to get this stuff cleaned up and see where I can go from there. See what I have. So this would be limit as x goes to 0 from the positive direction. Because that stuff's to the negative second power and it's in the bottom, it needs to go up top. So I have a minus x squared. And then I have 1 over cotangent. 1 over cotangent is the same as tangent. Tangent is sine over cosine. And then cosecant is 1 over sine squared. So just taking all my stuff and kind of rearranging it, and I continue to simplify here. Limit as x approaches 0 from the positive direction of negative x squared will go on top. The 1 sign on top will cancel with the 1 in the bottom. Actually, I can drop the negatives since I had 2 of them, so they're actually gone. And I just have an x squared. And one of the signs in the bottom will cancel with the 1 in the top, leaving me with just a cosine x, sine x in the bottom. So now that I've cleaned it up, I can see, what do I have now? What do I have? Well, as x goes to 0, the top is still 0. As x goes to 0, cosine goes to 1, but sine goes to 0. So we're still stuck with actually a 0 over 0 limit again. So we apply L'Hopital's rule another time and see what that does. We apply it another time and see what happens. Limit x approaches 0 from the positive direction of the derivative at the top, which would just be 2x, over the derivative of the bottom. That would be cosine times the derivative of sine, which would be cosine times cosine, or cosine squared. And then that would be plus sine times the derivative of cosine. The derivative of cosine is minus sine, so that's actually going to be sine times minus sine, so it'll be minus sine squared. And now finally, we can let x go to 0. Top will go to 0, the bottom will be 1 minus 0. Since it's no longer a 0 over 0 limit, we can just evaluate it, and we just get 0. So that means the original thing, the limit, as x approaches 0 from the positive direction of cotangent x raised to the x power, is equal to e to the 0, which means it's equal to 1. So we're actually going to the cotangent there. Cotangent is actually approaching 1, e to the 0, which is 1. Okay, so raise cotangent x to the x, you actually get 1, even though the original thing was an infinity to the 0 limit.